Alright, welcome. Time for another Algebra 2 video to help us through some lessons, and we're looking at lesson number 8 today. I'm going to work through this one pretty quickly because there's a lot of just practice that's going along with this, and I think that practice is going to go pretty fast. Excuse my voice, I'm still getting over a little bit of a cold here, but it is still me. So this one starts by thinking about how are these graphs the same and how are they different. We should recognize pretty quickly that this first one is not only a parabola, but it is also something that is telling us that we're looking at an equation that's something like an x squared going on. This is going to give us those different values. Remember, we're always picturing what we might be seeing that would change some of our values or help us know what kind of answers we're looking for. And in this case, we might have some values that are giving us answers with two possible answers. So if we had a line at 4, say, we would have two possible solutions. If we had something setting this parabola equal to 0, we would have one solution. And if we were down here at, say, -7, we would have no solutions. So a parabola would give us a possibility that we might have 0, 1, or 2 solutions. And it all depends on what number it is that we're looking for. If we're looking for positive values, we'll have 2. If we're looking for 0, we'll have 1. And if we're looking for negative numbers, we won't have any. And so, when we start also thinking about this on the other side here, we're looking at something that's more of a, this might be a familiar sight from our end behavior discussion before. We're looking at a cubic graph. So this is x cubed. Takes each of our values and it cubes it. And what we start seeing is that every single value that we would have on our y-axis, we are going to have one place where it's going to cross. So everywhere that we're looking with a cubic function is going to have one value. So when we're taking cube roots of things, we're only going to have one value, but we'll always have one value, even if our output is a negative. So even though it's going down here, we're still going to have values that take answers. So one solution always. I try not to use that word always too much because oftentimes I find there's an exception to the rule. But in this case, we will be finding one value each time. So even if we had, we'll see some of this coming up later. So right next door at 8.2, I see that we're starting to use this graph to start finding some cube roots. And it just asks me how many solutions are there to each of the following equations. And then to estimate the solutions from the graph that we have. And I notice all of these are cubic functions. Each one is something to the third. Now we just said each one of these is going to have one solution, so I can even actually fill this out. One solution, one solution, one solution, one solution, and one solution. Now estimating these from the graph, we can also check it by substituting it back in. So if I know that my y output is 8, and I'm looking for what my x would be when I have x cubed, using that in that horizontal line here at 8. Again, I'm putting my arrows in like I think we've done in earlier lessons. Finding that intersection point and then following it down until I find out that my value is x equals 2. Number 2 is looking at my y value at 2. Again, start at 2, follow it over till you hit your graph. I kept going, sorry about that. Follow it down, and I can estimate it's somewhere between 1 and 1.5. It looks pretty close to 1.5, so I'm going to say maybe x equals 1.4-ish. Now, I'm also wanting to know just how right I am. It says to check my answer by substituting it back in. So if I did 1.4 and raised it to the third power, I get something, pretty high. It looks like I went a little bit too high for that. So maybe it's a 1.3 to the third. That's looking a lot better. So I would have had a better estimate if I went with 1.3. Now when our x cubed equals 0, that's right here on the x-axis. Looks like it's got one solution, one input, one output. And 0 times 0 times 0 is in fact 0, so I'm feeling pretty good about that. Now at -8, if we were looking at a parabola, we wouldn't have had an answer at a negative, but this time we're in cubic. Negatives, no problem. Starting here at -8, following it over until I hit the graph. And this time I have to go up until I find my x value at -2. Now if I'm not sure, I should plug it in and check. Please be careful when you do this. If you just type in -2 and raise it to the third power, your calculator thinks that you just want to do 2 to the third power and then make it negative, because it's following order of operations. So please make sure that you are putting it in parentheses like this. So you're taking -2 times -2 times -2. Now I just noticed they're the same answer either way. That's what's so nice about cubic functions. Not only do they always have an answer, but because we have a negative times a negative times a negative, we're going to get a negative whether we have the parentheses or not. But it's still a good practice. Always good practice. And if we look at it at -2, starting here, follow it over until we hit the graph, follow it up until we find our y value, or x value, and I knew up here I guessed a little bit too high. I'm going to guess that it's somewhere right about there. So we're still back to using our graph and being able to follow those values over and around. Eight 8.3. We have another graph going on, still a cubic. Still see that end behavior that's down, up end behavior. And here we're using the graph of a cube root. Now we saw before that we had a square root that started here and only went this way. And I kind of wish our book had that graph in here side by side. So I'm going to put it side by side. This is what our square root looks like. And so it takes that same kind of shape up here. Our square root would have only been here in quadrant 1. And our cube root, since we can have negative values, continues that arc this way. So if this is our graph, we want to estimate our solution to when does it equal -4. Same procedures that we're starting, looking for our output of -4. When I work this way to hit the graph, this tells me that my input should be a -60. So I think the cube root of -60-ish, because I'm estimating, is going to equal 4. So I think x equals -60. Now, I'm already kind of thinking about what that might be. And finding the cube root of -60. I don't think I'm quite close enough. Remember these things, if we want to check them, they're in our math button here on our calculator. And number 4 is a cube root. Ooh, pretty close. -3.9. That's really close. I'm actually really happy with that. And so now we're thinking about the meaning of cube roots to find an exact solution to this cube root and how close was our estimate. I'd be thinking about finding 3 numbers that would multiply that equal that cube root. That idea of how we're going to be able to get closer than what I had already done. I mean, really, we're thinking about right? If we took that value to undo a cube root, we would cube both sides of the equation. That's our undo button kind of thing. And so cubing both sides of the equation would be the cube root of x raised to the third power. Those two cancel each other out. Cube roots and cubes are opposite operations. Negative 4 to the third power, we just saw, is negative 64. So our value should be negative 64. And our last question tells us to find the solution to the equation of the cube root of x equals 3.5. Using the meaning of cube roots, I'm going to use that same process that we just used above here. If I cube both sides, raise them both to the third power. On the left side, our cube root and our cube will cancel. And I'm looking at 3.5 raised to the third power. Nice terminating decimal there. And that says, use the graph to see if this seems reasonable or not. So if I put in my x at about 43-ish here, and follow it up until I hit the graph, and then trace that over, man, that is looking really darn close to 3.5, so that looks great. (8.4) is solving a bunch of cube roots. Now it says here that without solving, identify 3 that you think would be the least difficult to solve and the 3 that you think would be most difficult to solve. Be prepared to explain your reasoning. And it doesn't say that we have to solve all of these. Alright, so I'm only going to solve a few of them and then I'm going to put up a solution. So I'll hit pause on the video, solve them all here for you, and you can choose which ones you want to solve through. But when I think about which ones would be the easiest to solve up here, I am thinking about, let's see, I'd be looking for values that I know are very simple, that are going to be one-step kind of answers, right? So I would think that something like this would be fairly easy to solve. I know I need to subtract 9 from both sides and then find the cube root. This looks like it might be pretty easy to solve because it's ready to just be cubed on each side, some pretty low numbers. And what else might be easy to solve? Probably something simple like that guy. So they're pretty straightforward. These two at least have only one thing underneath the radical symbol, which might make it a little bit easier. Still have to do some work to start solving some of those. So if I were to solve something like, well, let's solve this guy here. If I were to solve this one, my first step, right now I have 6 and I'm subtracting this third root of b. And so I think I would start by adding the cube root of b to both sides. Cube root of b. That helps make it positive, which is a nice first step. And then if I cube everything, then I'll be ready to keep on going here. The cubes are going to cancel each other out, the cube root. And so I would have 6 to the third equals b. And when I do 6 to the third in my calculator, I have 216. So we can use the idea of cubing something to be the opposite operation of a cube root of something. If I pick another one of my easy ones, I think I'm going to go ahead and take care of this first one here. And I'm going to start with that same first step. Something that I might look at would be cubing both sides, so taking them both and raising them to the third power. Cube root, and to the third power cancel each other out. So on the left side I just have t plus 4 equals. And on the right side I have 3 to the third power. 3 times 3 is 9, times 3 is 27. So something plus 4 has to equal 27. T should equal 23. Loving this, coming up with one solution each time. It's so nice to work with cube roots. Now the ones that I think that might be a little bit harder to solve are the ones that have maybe something a little less familiar, like this negative in here. We'll have to see if that makes a difference. Or lots of things going on, like adding numbers before and after the cube root. So maybe this one would be a little more difficult. And maybe something unfamiliar, like this one down below. So I'm going to do quickly these two. They're on my difficult list. And then I'm going to hit pause and finish off the rest of these. You should do the same. When I think first about negatives, one way I can get rid of negatives, or at least move it to the other side, is to multiply both sides by a -1. Remember, if I do something to one side, I have to do it to the other. So I'm multiplying both sides by -1. That's going to make this a positive cube root of c equals a -5. Opposite of cube root is to cube it. Cube root of c to the third power means we're left with c on this side. And -5 raised to the third power, well, -5 times -5 is a positive 25. But multiplying that positive 25 by that third -5 brings me to a -125. Huh, that wasn't so bad. And solving this last guy up above, I'm going to copy that work down below because I'm starting to run out of space. But I have all this room down here, which is perfect. So, just copying how it starts. Now this one's interesting because it has a negative under the radical symbol. And I'm finding a cube root of a negative number. That can still happen, right? We saw in our graphs that all of our cube roots are here in quadrant 2 or in quadrant 3. So yeah, I'm going to come up with a negative answer because a negative times a negative times a negative will get me that negative number I'm looking for. So I'm going to move some numbers around first, thinking about opposite operations. I'm going to subtract 4 from both sides. I have another 4, so I'm going to subtract that one. I could have also just added them together and subtracted 8 in one step, but that's okay. Let's see, 2 minus 4 is going to get me a -2. And back to the opposite operations, keep on doing it. Cube root means we need to cube it all. And -m equals -2 times -2 times -2, -8. So a -m equals -8. That means a positive m equals a positive 8. And if you're like, Mrs. Derby, why? Remember, we can multiply both sides by a -1. Turns this side positive, turns that side positive. Alright, I'm going to hit pause. That's actually our last part in here, and we go right to the lesson summary. So I'm going to finish solving out the rest of those. If you want to take a look, you can certainly do that, and it'll be in just a few moments. Solve any more that you want to solve before we look at all the answers. It's always good to check your solutions. That's all I was doing. I did solve this last guy here in my workbook. So it was one of my other easy ones that I picked up. And I'm about to show you a lot of my work for all the rest of them. So If you solved for A, W, R, K, P, N, or S, here come those solutions. Feel free to pause the video so you can stop and look at my work that we have here. But I have them by the 2 columns. So this is everything in the first column and everything in the second column that I haven't already done. First portion, feel free to pause it. I'm about to slide it up so you can see the other half of my solutions right here. Each step worked out in a different color to help you out. That is lesson 8, friends. Enjoy doing some practice to make sure you've got this idea of cube roots and cubing.